3D geometries. The GMAT often tests on the knowledge of the geometries of 3D objects such as cylinders, cones, cubes, and spheres. The purpose of this is to summarize some of the important ideas and formulae which can act as a useful cheat sheet for such questions. Cube. A cube is a 3D generalization of a square and is characterized by the length of the side A. Important results include volume is equal to A cube, surface area is equal to 6A square, diagonal length is equal to root 3 into A. Cuboid. A cuboid is a 3D generalization of a rectangle and is characterized by the length of its sides. Important results include volume is equal to ABC, surface area is equal to 2 into AB plus BC plus CA, diagonal length is equal to square root of A square plus B square plus C square. A cylinder is a 3D object formed by rotating a rectangular sheet along one of its sides. It is characterized by the radius of the base r and the height h. Important results include volume is equal to pi r square h, outer surface area without bases is equal to 2 pi r h, outer surface area including bases is equal to 2 pi r into r plus h. Uh, a cone is a 3D object obtained by rotating a right-angled triangle around one of its sides. It is characterized by the radius of its base r and the height h. The hypotenuse of the triangle formed by the height and the radius running along the diagonal side of the cone is known as its lateral height. L is equal to square root of r square plus h square. Important results include volume is equal to 1/3 pi r square h. Outer surface area without base is equal to pi r L is equal to pi r into square root of r square plus h square. Outer surface area including base is equal to pi r into r plus L is equal to pi r into r plus square root of r square plus h square. Sphere. A sphere is a 3D generalization of a circle. It is characterized by its radius r. Important results include volume is equal to 4/3 pi r cube, surface area is equal to 4 pi r square. A hemisphere is a sphere cut in half and is also characterized by its radius r. Important results include volume is equal to 2/3 pi r cube, surface area without base is equal to 2 pi r square, surface area with base is equal to 3 pi r square. Some simple configurations are sphere inscribed in cube of side A. Its radius of sphere is A by 2. Cube inscribed in sphere of radius R. Side of cube is 2R by root 3. Cylinder inscribed in cube of side A. Radius of cylinder is A by 2. Height A. Cone inscribed in cube of side A. Radius of cone is A by 2. Height is A. Cylinder of radius R and sphere of radius R, where capital R and small r. The height of cylinder is 2 into square root of r square minus r square. Example, a certain right circular cylinder has a radius of 5 inches. There is oil filled in the cylinder to the height of 9 inches. If the oil is poured completely into a second right cylinder, then it will fill the second cylinder to a height of 4 inches. What is the radius of the second cylinder in inches? The volume of the liquid is constant. Initial volume is equal to 5 into 5 pi into 5 square into 9. New volume is equal to pi into r square into 4. So pi into 5 square into 9 is equal to pi into r square into 4. R is equal to 5 into 3 by 2 is equal to 7.5.